again, give a head up, and later we will have that review being done in more detailed geometry. But here I'll give a head up. P can be expressed by the quantity E minus E squared times A. Okay, so here let me plug in that information. So here that basically can be described by okay, so for the second options, then if we place the origin at the center there, then the equation of the orbits we have this relation here. The third one will be similar. So let me move the third one to here. The third one we define more quantities. So from the distance focus to perigee, we define the quantity as a Q. And again, those quantities will be used, those symbols will be used later on in our discussion of the geometry. So with this one, then we're using the displacement x minus Q. Okay, so compared to the first coordinates, we have the translation rule obtained by this one. So, so therefore, again, we equation 2 becomes R equal to P minus E times X. We plug in X equal to X prime plus Q. Okay, and then again, the Q is another parameter we described in the convex sections. So here, let me kind of give a head up. Q can be described by A times E minus E. So we use this equation here to plug in. Compared to the two quantities, we can have you can have this relation P equal to Q times 1 plus E. Okay, you compare the two quantities carefully, you should be able to get this one. So plug in that one. So here is Q1 plus E and minus E x double prime plus EQ. So therefore, R equal to Q minus E x prime. So from here you can see this is a very generic equation, and that is involve the two vectors and with certain parameters. In different coordinate systems, once you place the origins in the different places, basically you can see the three quantities, they are scalar quantities, involve the only x coordinate, the horizontal components of the coordinates. Okay, so in the second coordinate system, whatever the origin coordinates, so here R has the coordinate x prime and y prime, and this one y double prime has, and R has the coordinate x double prime, y double prime. Basically, for the three coordinates, the y are the same. So if you like, you can get rid of these things using the same y here. So if you like, you can use the same y, okay, because they have the same y coordinates. So the only thing matter is their x coordinates. And only in this equation we involve is the x component. And however, the first quantity will involve with different ones. So here is the tables, I would say, will be the part of the information in the cheat sheet. And that is up to you, which depends on which options you want to use and for whatever the question, okay? And those things will be a preparation for our talking about the geometry. So next one, I will I will save this and then using these portions to give a little bit more about the geometry. Another information we're going to use later on is this. We call the focus. Directrix properties, and probably you will forget what that means, but let me give this to you. Say if this is an orbit, okay, and say for this one I take this option to place the coordinate systems. So here, this is the perigee, and perigee here. So we place, this is the focus. So if I take the option 1, so this is our coordinate systems. And say this is x-axis and this is y-axis. Okay. And so to talk about this one, then we can see what happens. So based upon right now, you can see I have this one. So basically, that is our option 1 in placing the coordinate systems. Okay. So that means from equation 2. We have to use that equation r equal to t minus ex. Let me copy that one over here. For this one, we arbitrarily locate a point, say any point on the orbit, and here I locate there. And the first step is I try to manipulate these informations, and those information, the focus directrix properties were derived in the period of the 1500 or 1400, many years ago, 600 years ago. And they simply just use the pure geometry. By the way, if you would have any chance before, but probably don't, I can share with you. In attending, have you heard about the Olympic test or Olympic testing mathematics, or I think in mathematics, and they have on the local to regional to national and to international. Those one is for those kind of the mathematician nerds in that one. Many of the questions in those tests are from the pure geometry and actually inspired from those exercises a couple hundred years ago, just totally on the pure geometry and so many angles, so many auxiliary lines for making some kind of good properties. Okay, so this is one. So here I directly give you the result, and step one, I'm going to do, don't ask me why, but that's a summary. Okay. The step one is I'm going to place a line. Location of the line is perpendicular to x-axis, and by how much distance from the distance here, and that is by P over E. Okay, and that is the result of people's finding, and here directly summarize it to you. So don't ask me why, I simply take it. Okay. So the step one, the step of the analysis is this: we place the line is called the directrix. Okay. The second one is we place an arbitrary point. So this point, let me call the point called P. Say any point P, and then this has the coordinate xy. Okay, the measurement of xy with respect to the origin here. So that is also the origin. The third one is let the distance x. So here this is our r, the distance r, and then the distance x is simply here. Okay, so and let me give the point. So say this is P and this is the focus point F. And from P here, I project his location to the directrix, and let me call it N. So this is project point of P to the directrix, and let me call it P. So therefore, from here you can see the Pn and this P. Pn equal to the difference between this one minus x, so Pn equal to P over E minus x. Can I change the symbols not to confuse any, to have no confusions? Let me change this one. Say it's not P. How about say A? Okay. So because we have 2P, P is actually P here is the parameters. Equal to h squared divided by mu. Okay, so I want to avoid that kind of confusion. So let me call this is A. So basically AN equal to the distance difference between this one and this one. So that's P over E minus X. And so this one we can do the calculations, and this one equal to how much? P over E, basically here we use equation 2, so that is equation 2. From equation 2, here we have P equal to R plus EX and minus E minus X. Okay, so here I introduce the equation 2 for P. So here we can see that one equal to R over E. So therefore, you can see we compare the ratios. The distance between a point on the orbit to the focus to the distance to a spatial line, we call it directrix, and that one equal to how much? AF equal to R, and AN equal to R over E, that is E. E is our eccentricity. So this is called the focus directrix properties, and this is saying that AF is the distance from to the focus. AN is the distance to the directrix. So combine the two things, we call the focus directrix properties. Says that the orbit is the locus of point where okay, so basically saying is this one. So this is a simple word, the equation for this quantity. So that is also a rule to draw the orbits of a locus. So say on the drawing, you simply arbitrarily place the coordinate systems. Okay, so this is one focus. And then you simply arbitrarily place like that called the directrix. Then you pick up any number e, as long as e is greater than 0, 0, 0.5, okay, 1, 1.3, etc. Then you simply stick with this rule, then you begin to trace the point of whatever fitting into that rule. Collection of those rules will be forming as the orbit. The orbit has the eccentricity equal to whatever you use. Okay, so if you use E equal to between 0 and 1, then actually you will find is the electric orbit, and this is one focus. If you're going to choose E equal to 1, then you will find is parabolic and parabola, and then etc. If E equal to greater than 1, then you will see is a hyperbola. Okay, so give a try. And